Hello and welcome to the Data Science Interview Prep Podcast. In this series, we go through topics that are commonly discussed in data science interviews, and we give a high-level overview on those subjects. In today's episode, we'll be discussing random forests, which is a topic that appears quite often in interviews. Before we jump into things, though, I just wanted to take a moment to thank you all for listening and for your support of our podcast. If you find our content helpful for you in your data science journey, please consider subscribing to our paid membership or support us on Patreon. We would really appreciate your support, and it would help us a lot to provide you with useful interview prep content on this channel. All right, so with that being said, let's dive into today's topic, random forests. Random forests are one of the most popular and widely used machine learning algorithms, and for good reason as well. Today, we will discuss what random forest is, how it works, and what makes it so effective. So, random forest is a type of ensemble learning algorithm that combines multiple decision trees. By combining multiple decision trees instead of relying on a single tree, we are able to improve the accuracy and robustness of the model. Due to its robustness, random forest has become a popular algorithm for classification, for regression, and feature selection problems in machine learning. So, how does random forest work? In a nutshell, it works by building several decision trees at training time and kind of taking a vote on these decision tree predictions. In the case of classification, random forest outputs the class that is the mode of the classes, and in the case of regression problems, random forest predicts the mean of the individual trees. It gets an aggregate representation of each of the decisions made by the individual trees, which results in our final model prediction. The key feature of random forests is that each decision tree in the forest is built using a random subset of the features from the training dataset. This process is called feature bagging, and it reduces the correlation between the decision trees and it prevents overfitting. So each tree in the random forest is made using a different bootstrap sample of the training data, which again helps to reduce overfitting and improves generalization of the model. And if you aren't clear on what we mean by a bootstrap sample, let's take a quick moment to understand what this is. So, bootstrap sampling is a statistical technique that involves randomly sampling data from a dataset with replacement to create a new bootstrap sample. And it's really important to remember that we sample with replacement here. So, to give a little more context on this, let's look at an example. Imagine that you have a dataset of 100 observations. To create a bootstrap sample, you would randomly select 100 observations from the dataset with replacement. So this means that each time you draw a sample, you put the observation back into the original dataset before drawing the next sample. And doing this allows the same observation to be selected multiple times in the new sample. And when you repeat this process many times, you get a fairly representative idea of your dataset. So to help you think about this, you can imagine a big bag filled with different colored balls. Say that you have 100 total balls in this bag. A bootstrap sample would be if you sample with replacement from your original bag. And the with replacement part, again, is really critical here because when you do this type of sampling, you're taking a random subset of the original data, but you can get the same item twice. So if you have different colored balls in your bag, red, green, blue, so forth, you can get two of the same exact item in a bootstrap sample. And by running this process multiple times, you can create many different bootstrap samples, which is what we do in a random forest model. So with that being said, let's now dive a bit deeper into the random forest algorithm and explore its benefits. One of the significant advantages of random forest is its ability to handle high-dimensional data with relative ease. Given that the random forest uses the bagging technique, they can handle a large number of input variables without overfitting, which makes it a really popular choice for feature selection. Random forest also has really good accuracy and robustness compared to other machine learning algorithms, and the model is able to handle noise, missing values, and outliers in the data, making it a reliable algorithm for real-world problems. On top of all this, random forest can provide useful information about the importance of the input variables. So despite all of its upsides, there are some cautions to keep in mind of the random forest model. For example, one of the limitations of the random forest model is that it can be a little bit hard to explain to stakeholders who may not be technically inclined. Another limitation of the random forest is that it might not perform so well on smaller datasets. The random forest requires a large amount of data to work effectively, so it might not be suitable for datasets with a limited number of samples. Okay, so to sum up today's discussion, we learned that random forest is a powerful machine learning algorithm that can work on classification and regression problems. It's also even useful in feature selection. We also learned that random forest is an ensemble model, and its strength comes from building several decision trees using random subsets of the training data, and finally taking a vote on all these trees to provide a final prediction. Also, the fact that the random forest algorithm can handle high-dimensional data, noise, and missing values makes it a popular choice for real-world problems. While it has some limitations, like its lack of easy interpretation for non-technical stakeholders and requirements for large datasets, it's still a really great choice for practical machine learning problems. So that sums it up for today's discussion. Thanks for tuning in to today's episode of the Data Science Interview Prep Podcast. We hope you found this episode on random forest helpful and informative. Be sure to join us next week where we will discuss other interesting topics in the field of data science. Until then, happy modeling!